We are on a journey going back billions of years here on The Morning Show. I'm Kate Archer-Kent. We're learning about the formation and evolution of the Magellanic Stream. It's this long, flowy ribbon of gas stretching nearly halfway around the Milky Way galaxy. And the incredible Milky Way is one of the closest galaxies to us here on Earth. What do you want to know about the origin of the Magellanic Stream and why it matters? What makes you curious about the Milky Way? Is there life on Venus? We're at 800-642-1234. Elena Dongia is an associate professor of astronomy at UW-Madison, and her research stretches into the vastness of space outside of our solar system. Elena, welcome to the Ideas Network.
Hi, good morning, everyone.
Well, we just learned today the Nobel Prize in Physics this morning just out. The scientists had developed methods to see through the huge clouds of gas and dust to the center of the Milky Way. What do you think of the prize?
Well, I'm actually quite surprised, but I haven't looked at the news yet. But yeah, so it's I'm happy if it's about the Galactic Center because it's an amazing research that should be awarded at a certain point. So that's fantastic. Last year we have cosmology, so eventually this year it's going to be about the galaxy. So.
Well, let's go to Venus, if we could, for a moment, because there was news out recently that there might be signs of life. What is it that has scientists looking more closely at Venus?
Okay, I found very fascinating this article on Nature Astronomy because it brings us back to a memory about the idea of finding life really on planets that are very close to the Earth, like Venus. There was a lot of imagination in the 60s about if it's possible to have life on Venus, and then it turned out that the atmosphere is so acidic and so so difficult for hosting life. So this paper was about this publication was about the detection of phosphine gas, which is it turns out that it's a gas that on Earth is actually produced by a community of microbes eventually, or it's also found in the guts of animals, and so it is really associated some way with the evidence of life going on a planet. But of course, there's a lot of caution in the community because while it's very exciting to see these traces of phosphine gas on the atmosphere of Venus, on the clouds, it's also, one has to be conscious that there are maybe eventually other things we don't know. Scientists are trying to understand if there are unknown reactions that could bring to the formation of this phosphine gas that are not associated necessarily with life. But definitely it's extremely surprising, and on a planet that it's it is not supposed to be hosting life, as we know, that could have these traces of this gas.
Well, Venus itself is like a blast furnace, crazy hot, but apparently there's this top of its layer of clouds in its atmosphere that may only reach temperatures in the upper 80s, which scientists have theorized that might be able to have life exist, and with ground basically pressures similar to what we experience here on Earth. Is there anything to that?
Yes, I think it is interesting because yes, if there are microbes or if there are that kind of life on Venus, it's in these clouds on the atmosphere, because as you said, the temperature would be too high on the surface to actually allow the molecules to not to break apart. So molecules would break apart actually on the surface of Venus. But the idea that there might be eventually microbes or life in that sense on the surface, on the clouds, now it's very appealing. And this is why this paper, although the phosphine traces are very, my understanding is that they are it's a tiny fraction, so there's no a huge amount, but still interesting in itself. So I I think as every discovery, it needs to have follow-ups to confirm it. So definitely it is interesting.
We're talking with Elena Dongia, who's an associate professor of astronomy at UW-Madison. We're discussing the possibility of life on Venus. We're going to be looking at the developments with the Milky Way. Do you think we're alone in the universe, or might we have galactic neighbors? Would you like to travel to another planet? What do you want to know about the Milky Way and about Venus? How about telescopes? What questions do you have about the telescopes used? We're at 800-642-1234. So, Elena, how did the scientists find this gas in the Venus atmosphere? What technology did they use?
They used telescopes, so they really did it from Earth. And this is actually, I would say this is the beauty of our era, that we, so far we did not have to go with spacecrafts inside Venus. We did it in the past, but now, we have the ability to also to have telescopes quite good on Earth to check, to make science. However, I think this discovery opens up the possibility, at least it makes it so appealing, the outcome that eventually a mission to Venus will be prioritized eventually, and to send the spacecraft there to really eventually to take more to analyze better these clouds of Venus.
How would you take?
It opens up.
Yeah, how would you take spacecrafts there to Venus?
I think there are, we already send web missions that are going to various planets on the solar system. That's not only Venus. We have Juno. We have, Mars. We send. We don't send humans yet, but we send. For science, we had missions that allows. These let's call them spacecrafts with the scientific instrumentation to go on planets. So that's one of the things that have been very active in the last decades, from Europe, but also, some missions from US as well. So this is not impossible. It's quite difficult right now to send humans to other planets. We only explored really just the moon, but that was back to 50 years ago.
Sure. So if there are traces of phosphine, what is the next gas to look for?
I think, this is a good question. I think what they want to see is eventually if this gas phosphine, if there are other ways to get this gas phosphine that are associated to, if this is really associated to life. Of course, there are other, as life as we know it on Earth, because I think we have always to remember that we know life on Earth as it was. We don't even know exactly how it was formed on Earth, but we know what are the elements that make life possible on Earth. But other elements, it could be oxygen. There are other elements that are more related to what we have on Earth. So those will be follow up. Well, we know that there's not much of that on this planet.
We are exploring what's on Venus and developments with understanding the Milky Way with UW-Madison astronomer Elena Dongia. Elena and her fellow scientists have a new paper in the journal Nature about the two most massive satellite galaxies of the Milky Way, how they came to be. What do you want to know about the halo of warm gas called the Magellanic Corona? What do you think about the Hubble Space Telescope? Join in at 800-642-1234. Back in a minute on the Ideas Network. If you're just joining us, we've gone back billions of years ago. We're unlocking the mystery of a pair of dwarf galaxies known as the Magellanic Clouds. It's a conversation about our galactic neighborhood here on The Morning Show. I'm Kate Archer-Kent. So along this journey, the Milky Way stripped off a massive stream of gas called the Magellanic Stream from the galaxies. And now scientists think they can explain a halo of warm gas surrounding the two Magellanic Clouds. What do you want to learn about the long ribbon of gas stretching nearly halfway around our Milky Way? Are you curious about how scientists detect whether there is life on other planets? Join in at any point, 800-642-1234. We have Elena Dongia, who's an associate professor of astronomy at UW-Madison, one of the researchers who published a paper in the journal Nature on the formation of the Magellanic Stream. So, Elena, let's talk more about this Magellanic Stream. Can you give us some of the nuts and bolts and explain it to us?
Yes, but let me clarify one thing, because I checked in the meantime, the news, and indeed, it's amazing. So the Nobel Prize for Physics is kind of surprising to me, but it's amazing that it's really given to people that study the central black hole of our galaxy. It's, in particular, Rainer Genzel and Andrea Goetz. Genzel was at the Max Planck, is still the director at Max Planck Institute in Germany, and Andrea Goetz is actually UCLA professor. It's an amazing research, because for many years they have really looked into evidence for the supermassive black hole in the center of our galaxy, and they really provided indirect evidence of it. And now finally, because of the last few years where we really see the images of the black hole, I think they've been awarded for the Nobel Prize. So I'm very happy for
why are black holes so important to study?
Oh, they are amazing, because every galaxy has a black hole, a central, very massive black hole. And so we don't really know exactly why. So how they grow, and they are also validating actually the general relativity from Albert Einstein. So it's really I think a very fascinating research of this century. And that really this century started with the discovery of the view of a black hole, I would say, a few years ago. And so now all this research has been awarded. Black holes are amazing because, they really challenge our understanding of physics. And they are extremely conditions of extreme, where the gravity is extremely high. Light does not go out from a black hole, so they are very difficult to spot. But we can feel them gravitationally, so they feel the same gravity. So they are extremely high gravity systems. So, and this is what these people have done. They basically have looked at, they really follow the stars going around the black hole and in our galaxy, and they saw that the stars were deviating, were going on an orbit that could be only explained if something extremely massive was at the center of the galaxy. And so they finally admitted that there must be a supermassive black hole there. And now we know, we have seen the image a couple of years ago. So now finally they've been awarded for their research.
Well, take us to the Milky Way, if you will,
yes,
and explain what you're seeing there with the Magellanic Stream.
The Magellanic Stream is this amazing gas that it's really stretching on the sky, but we cannot see it with the eyes, because our eyes only see in a narrow range of the spectrum, just in the visible spectrum. So the stream is more seen in the radio emission, but it really stretches on the sky, and it's associated to the large and small Magellanic Clouds, which are actually the closest companion of the Milky Way. They are dwarf galaxies. They are orbiting around us. So this amazing gas is a reservoir for our galaxy, for the Milky Way. And it's a reservoir of gas that is a 50 years old mystery, because we never really understood since the 70s, when it was discovered with the radio telescopes. We didn't know exactly what the origin is. And it's a huge amount of reservoir of gas. It's so important because the Milky Way right now does not form many stars. We are not so active in that sense in our galaxy. But this reservoir of gas, once it falls down into the Milky Way, we reactivated the formation of the stars in our galaxy. So it's an interesting reservoir that that our galaxy is keeping there, and we didn't know the origin. So with our work, I think we have some way. I wouldn't say we have completely solved the problem, but at least we are going forward the solution right now, because it seems,
Well, I just want to reintroduce you for one moment here. We're talking with Elena Dongia, who's an associate professor of astronomy at UW-Madison. We're discussing news about the Milky Way. We've also been discussing whether there could be life on Venus, taking your questions as well. Do you ever look up at the night and wonder what's past the stars? What have you read and heard about the discovery of gas in the Venus atmosphere? And what questions do you have about the Milky Way? Join in at 800-642-1234. Elena, your research really looked at the Magellanic corona, or this like halo of warm gas. What is this halo?
This halo is a reservoir of gas, again, around each massive galaxy should have its own cocoon of gas, warm gas around it. And the Magellanic Cloud, the Large Magellanic Cloud, seems to be massive enough this day. We have hints about it that it should have its own cocoon. And this paper is about this. So it's speculating that there must be a cocoon of gas that came with the Large Magellanic Cloud, and because the clouds are just a recent companion of our Milky Way, this cocoon has been brought with the clouds into the Milky Way, and it's actually forming the majority of the stream.
Wait, you just said a recent companion to the Milky Way?
Yes, the recent companion, and thanks to the Hubble Space Telescope and the research on the Hubble Space Telescope in the last 10 years, we know that we could measure the motion of the clouds, how fast they're moving. And we realized that in the last decade that they are moving faster than expected. So this means that they are just a recent companion. They are not ancient companion of the Milky Way. They're just recent, I'm saying, in the last, let's say, 1 or 2 billion years.
Oh, yeah, it's totally recent.
Yes.
Astronomically speaking, of course.
Yes.
So why is it important, though, to know about these clouds and their impact? I mean, why should we be studying these clouds so closely and their movements?
Well, they're telling us how our galaxy is forming, is evolving, how might have been formed in the past, probably by accretion of dwarf galaxies like the clouds. So it's really about the formation of our galaxy, but it also tells us about the future of our galaxy. So the Magellanic Clouds, at certain point, they will merge in our galaxy, and actually, as they are coming in, they are bringing also a lot of stars. And they're bringing stars, but they're also bringing, gas, as we can see. And one day when they will completely merge in our galaxy, they will form the sky of the stars of the, additional stars on the sky around in the Milky Way, in the entire Milky Way. So they're really important they're the building blocks, say, these dwarf galaxies of our galaxy. So they tell us about also what happened in the past with previous galaxies that have been merged and forming the skeleton of our own galaxy.
It's really interesting that they bring cargo with them. They bring stars, they've got gas, they have things along for the ride, it seems.
Yes, exactly. So they visit, but they also bring us something. So they're visiting, and eventually at a certain point they will merge. So gravity is pretty strong, so they will not escape.
How important? Yeah, how important was the Hubble telescope to these discoveries?
It's been crucial. So the paper we pointed out is the paper we wrote is about really an idea. So this is just a theory about the cargo, but we have already hints about this gas that should be really around the Milky Way, around the Magellanic Clouds, thanks to the Hubble Space Telescope. Because the Hubble Space Telescope allowed us in the last 10 years to measure what are the elements, we talked about phosphine in the past, right? But we are, and now with HST, we could measure which are the abundance, the chemical elements that the stream is made of. And we saw that it's, thanks to the Hubble Space Telescope, we saw that, it's carbon, silicon. We saw the chemical composition of the gas. Also, we could see how hot is the gas. So And in future, next year, we have already a project with the Hubble Space Telescope that we will determine next really what is the temperature in details, what is the density of this gas. So we will know exactly of the corona. So we will know exactly everything about all the properties about this cocoon. And hopefully we will confirm the discovery that there is a Magellanic corona around the clouds.
We are learning about the origin of the Magellanic Stream with UW-Madison professor Elena D'Anghia. Elena and fellow scientists, as we've been talking, have a new paper in the journal Nature about the two most massive satellite galaxies, the Milky Way, and how they formed and evolved. What do you want to learn about this halo of warm gas and how the Magellanic Stream became so massive? What do you think of the role of the Hubble Space Telescope here? Be part of this at 800-642-1234. We'll pick this up on the Milky Way right after this news update. Stay with us on the Ideas Network. Exploring our galactic neighborhood this hour of the morning show. I'm Kate Archer-Kent. In the early 70s, scientists discovered a long ribbon of gas stretching nearly halfway around the galaxy with their telescopes. And fast forward to today, and researchers think they know why the Magellanic Stream came to be so massive. Their findings in the journal Nature key in on the Magellanic corona that we've been talking about, this halo of warm gas that seemed to fuel the growth of the Magellanic Stream. What questions do you have about the Milky Way? What have you observed in the night sky? How do you think the Hubble telescope is advancing astronomy? What do you want to know about its use? Join in at 800-642-1234. Elena D'Anghia is an associate professor of astronomy at UW-Madison, and she's one of the scientists working on the Magellanic Stream, and she's our guide. So, Elena, talking about the Nobel Prize in Physics here for a moment and these black holes, with the Milky Way, there's this supermassive black hole. It's 4 times our sun's mass in the center of the Milky Way. Are these common in our universe?
Every galaxy do have a black hole at the center. Now, the Milky Way has a black hole that it is massive, but I wouldn't say that it's super massive, because our galaxy is not that huge. But as you go to larger, more massive galaxies, even this black hole is really super massive, and it's billions of mass of the sun. And it's very interesting because we don't really know how they formed. And as I said, their gravitational effect is very interesting for stars that are very close in the vicinity of the black hole.
Could there be a second companion black hole next to it?
There could be, yes. There are ideas that there are binaries black hole that eventually they coalesce and they merge, but they are very difficult to spot. However, with the gravitational waves discovery, we know now that in faraway galaxies, they emit, one of the outcome is actually the gravitational waves. And this is the way that, now this research has taken advantage from the discovery and really from that we know that when they merge, they might have emitted gravitational waves. And that's the way that basically they could be spotted, because they're very fast emerging at a certain point. So they're very massive beasts.
They're massive beasts. So, when you were talking about the Hubble Space Telescope and how it has really helped the work of scientists, who gets the priority to use the Hubble? What projects take precedent?
The most interesting, or at least the topics that are really hot, or that the community urges an answer about. There are various ways to get time at the telescope. The telescopes, so you can get orbits, so you can basically request for your science, and if you are awarded during the orbits of the Hubble Space Telescope on space, they will take some of the data for you, and they will send it to the astronomers. Otherwise, it's so great, the Hubble Space Telescope, that it's around for more than 25 years now. So all the data that have been collected are also on an archive. And so it's also possible just to take the data already collected for your science. So make a case for the science why you need those data, and then you just, request those data particularly to make a rediscovery, or simply to look at the data for something new that you were thinking that could be interesting for science. So that's the way basically that the telescope works.
And about a year from now, NASA is scheduled to send a new super telescope into orbit. It's named the James Webb Space Telescope. What is this? What will this telescope enable you to do?
So this telescope will be the new generation of the Hubble. It's much more powerful, 100 times more powerful than Hubble.
Wow.
I'm very proud because it's an American. It's really from this country. It's an American telescope. So and it's going to be amazing because it's much more. It will have a larger mirror. So it will collect many more photons, so much more information about the universe. Will allow us to go much further, much more deep into space to see systems, and it will be located more farther out than the Hubble Space Telescope. So it's really the new generation, and we're waiting for years now to have it in function, and hopefully really, and it should be possible since next year on. It will open a lot of windows on deeper research that and especially bringing this country again, at the leadership.
We're talking with Elena D'Anghia, who's an associate professor of astronomy at UW-Madison. We're talking about her research that stretches into the vastness of space outside of our solar system, taking your questions as well about astronomy. Do you wonder about how scientists can be so sure about things like the composition of different gases in space when they're light years away? What do you want to know about the formation of stars or our solar system? Join in at 800-642-1234. You can email ideas at WPR.org. Elena, the James Webb Telescope has a much larger mirror than the Hubble, I understand. Why does that matter?
Well, it matters because larger mirror means that it collects, so the area that can collect photons, that is the light, that's what we observe, is much larger. And so it's like if you could collect much more, information. So it's like when you have you take a camera, you take a picture with a camera. If you have a larger collecting area, you are, getting more information. Your picture is better. So it's a way to for us to photograph the sky deeper. And so we can start seeing details that we haven't seen before. In particular, it will be possible to see, deeper in space means going back in time. So it will be possible to go in the early phases of the universe and see how the universe was. It's like, taking a picture very, very deep means looking at very far away, and means going back in time, looking at, in this journey. So it will allow us also to see atmospheres of planets. So that's very important for the research, for searching for life on different planets, and we'll see also early galaxies. So we'll go so back in time that will be much more. There will be much more information about those systems that right now
much fuller picture. Yeah.
Much broader picture, yes.
Let's bring in Rose now, who's joining us from Chatfield, Minnesota. Hi, Rose.
Good morning. I think astronomy should be taught right away in school. Everyone in the world can see the sky. And I send the sky calendar from the Abrams Planetarium to all of my friends. It's just $12 a month. And this last night I saw Mars. I live in a third-floor apartment facing east. And then this morning I saw Venus. And I know there are 88 constellations, but it's something that, and I tell children here, and I say, be sure and look up and see the stars. And I think it's very important. I think it should be taught right away in school.
Rose, do you use a telescope, or is this the naked eye?
I don't. I don't use a telescope. I have binoculars.
Okay.
But I had a telescope a long time ago, but I've studied astronomy a long, long time.
Rose, thank you so much. Elena, Rose really appreciates the looking up at the night sky and thinks children should too be taught at a very young age.
I totally agree. Also, because I think, in the ancient times, centuries ago, I think before, the towns and the cities developed with all the pollution for light on the sky, it was possible really. The sky looked like so bright, and I think fascinated a lot the human being. And this is why astronomy is one of the most ancient, branches, because people were just, the human being was just fascinating looking at the sky because it looks so bright. These days, unfortunately, there's a lot of pollution in cities. To really see the sky well and be fascinated from it, you have to go on the mountains, or you have to go on the desert, and that's where telescopes are. So I think I agree with Rosie, because we have to give back that imagination and mystery and fascination to children that don't see the sky so well in this generation.
Rose, thanks. Let's go to Peter now in Green Bay. Hi, Peter.
Good morning. Thank you for the program.
Sure.
Could you please explain in a little bit more detail what black holes actually are? And what I've never understood is, how can anything exist if you have a black hole in your neighborhood? How does it not just engulf everything?
Great question.
Yeah. Yes. So black holes, ordinary black holes, are the end of the life of massive stars. So stars, they are born with various masses. Our sun will never become a black hole, but more massive stars, when they explode in supernova, they can form, the leftover can be a black hole. And so they are leftover of stars. However, the ones that are, wandering around in the galaxy, around even, not in our solar system, of course, but in our, even around, far away from the sun, but, in the galaxy, like other stars. Those are not very dangerous because they are very small, after all. They're just imploded star, just leftover of a star. However, at the center of galaxies, these black holes are instead huge, very massive. And so those are more, not dangerous, but they're more fascinating because there's a lot of gravity there.
Elena Dangia is with us, UW-Madison astronomer. What do you want to know about black holes, about telescopes? What puzzles you about the Milky Way, one of the closest galaxies to us here on Earth? Still time to talk, 800-642-1234. We'll be back in a moment with Elena Dangia here on the Ideas Network. It's the morning show. I'm Kate Archer-Kent. Let's get back to our conversation now with Elena Dangia as she explains Magellanic Clouds, the Milky Way. Elena and fellow scientists are explaining why the Magellanic Stream became so massive with their numerical calculations and with the help of the Hubble Space Telescope. Elena, you were answering there Peter's question about black holes and that they thrive under intense pressure. Can you explain this pressure? Yes, so this pressure is different from the pressure that we see on Earth because it is really the density of these objects is so high that the ordinary matter that we know, like the atoms, electrons and neutrons, so they are so packed that these circumstances we don't see them on Earth. In these conditions of very high density, there's a different kind of pressure, and it's not related to the temperature. Usually pressure on Earth in our physics, ordinary physics, is related to temperature. In these systems, it's not related to temperature, it's really related to density. And that's why they are objects completely imploded. Now, the supermassive black hole are probably the outcome of a lot of merging of, it's the outcome really of
pile up of many black holes, or a lot of gas that entered into that singularity, that single point.
Mm-hmm.
And we don't really know how it happens.
Lots of mystery there. Yeah.
It's a mystery.
Let's bring in Dennis now in Pensacola. Dennis, hi.
Hi, thanks for taking my call.
Sure.
My question is, since these black holes are gobbling up a lot of mass and are so dense, is there atomic fusion taking place within a black hole, such as takes place within the sun?
No, there's no. They are really the fusion of elements. The fusion inside these black holes happened before they were black holes, when they were a star. During the life of a star, a star very massive has a very short life. So in a very short time, in a few million years, basically produces, it goes, from producing first hydrogen into helium and then heavier and heavier elements. And then it explodes, it gives a supernova, and then remains a black hole. And so at that point, it's just the leftover. It's just a dead star. Black holes are dead stars initially. Now, the supermassive black holes are a dead star. Who knows how it started, and then, eventually like a star, but then, it piled up other material, it ate something more. Much more to get, such a
so
huge
hungry.
Mass. So hungry. So, but there's we don't really, to be honest, we don't really know what is inside the black hole, because the fascinating part of the black holes is also that as soon as you try to get closer, let's suppose that now we send a spacecraft to black hole and we want to get into the black hole. The gravity is so high that one of the jokes of gravity is that getting closer and closer to a black hole, the time delays. So to be honest, really, once you try to enter into the black hole, it's like if this journey will happen forever if you are inside the spacecraft. So it's very fascinating.
Talk about a scientific experiment that will never end.
Yes, exactly.
We're talking with Elena Dongia, who's an associate professor of astronomy at UW-Madison. We're discussing mysteries of our solar system this hour, black holes, the Milky Way, is there life on Venus, and taking your calls, 800-642-1234. Let's bring in Joe now, joining us from Neenah this morning. Hi, Joe.
Good morning. Say, Elena, when companies like SpaceX launch hundreds of satellites into the sky, Starlink, for example, that's going to pollute the sight of the sky. What do astronomers think of that? I mean, we put up with Motorola's Iridium satellites when they used to flash, and we could predict those. But Starlink is hundreds, if not 1,000 satellites up there. What do you think of that?
We are very angry. The community is very angry, complained, because, yes, you are absolutely right. So this is a disaster. It's a disaster. If companies start without any regulation, polluting the sky, they are going to affect the radio observations on the ground.
Right. It seems like there's light pollution on the ground. There's going to be object pollution in space with all of these objects circling the Earth. It's terrible. I don't know what to do about it.
It is really terrible, and there's no regulation so far. I think I believe the government is taking some restrictions, but so far there were no restrictions, and these companies are just taking advantage. They just don't care. So they just really don't care.
Elena, what does it do to impede your science, your astronomy, when there are so many of these satellites up there?
Well, they start polluting, the images, and especially for radio astronomers, this could be a big problem. For images, taken out of the Earth, not on the ground, like the HST, that should not be eventually a problem. But for telescopes on the ground, it is a problem, and it's because you can see images that are basically the light get polluted from intruders, from additional from things that shouldn't be there. So that becomes more difficult to disentangle, and the clarity of the images can also be deteriorated. So it is really against science, I would say.
So the James Webb Space Telescope will be able to give you better imaging than from the ground. But, as we talked about earlier, this telescope...
this is in space. So
in space, yes. Yeah. But it's going to cost almost $10 billion for the life of the project. Can you explain why is it so expensive?
It came so expensive, I think, because of several delays and mechanical problems. You have to understand that NASA before, and I really appreciate that, NASA is an organization that before sending anything in space, has to be, every telescope has to pass a lot of tests. And so you don't want to fail a mission, And so because of that, there were many delays, unfortunately, for various reasons, and has been delayed. And delays, in this kind of missions, unfortunately, means more money. But I think it's really important. Last year, I went to the Senate to fight, with other scientists. I went to the senators of Wisconsin, at the Senate, really to fight to get James Webb, and also WFIRST is another mission of US, because, we have to, if we want really that our country still keeps the leadership, we need to do missions. You have to invest in telescopes and missions on space. Otherwise, other countries will actually, Europe is really leading right now. So it is important also for our community.
So, Elena, in our last minute we have with you, what do you work on next? And where does your science go from here?
So my science goes in trying to understand better, first, if there is a confirmation of this warm corona around the Large Magellanic Clouds, that will be a new discovery in the sense that we confirm it, that there is this system that we have to take into account in astronomy. I'm also working on thinking about strategies to shield the spacecrafts from cosmic rays. These are radiation in space that can deteriorate instrumentation, but also it's very harmful for human beings. So if we're thinking about going, on Mars one day, with human beings, we need to solve the problem of the radiation that's very harmful to the human body.
I assume you're on with a whole team of scientists working on this.
Yes, I'm working with a team of UW with IceCube. So people working on IceCube, they are experts on radiation, and I'm also a physicist, and so we are thinking about strategies for allowing our civilization also to see eventually other planets in person one day.
Elena, thank you so much for joining us.
Thank you.
Elena D'Anghia is an associate professor of astronomy at UW-Madison. We have a link, by the way, to the paper by Elena and her colleagues published last month in the journal Nature. It's called The Magellanic Corona as the Key to the Formation of the Magellanic Stream. And that's at wpr.org/mornings. I'm Kate Archer-Kent. This is The Morning Show. You're listening to the Ideas Network.